So, moin! This video is part of the Scientific Python programming lecture at the University of Bremen. And at this session we would like to treat exceptions and talk about exceptions a little bit. We will see that exceptions are basically a way to handle errors which occur in Python, actually in two ways. First of all, treating errors smoothly, which occur although if something unexpected happens, which we could not prepare for. And the other use which we will see is that we can, so to say, raise exceptions to signalize the program that we were treating, and basically we were ending up with a condition where we cannot continue normal program execution. As always, we will work in our virtual box in order to demonstrate those principles, so please start your virtual box so that you can follow whatever I do. As always, you can download the slides basically from the website of the course, and therefore please also download the slides that you can follow that. And in this set of slides we have two topics, the exceptions and the API documentation via Sphinx. In this video I will talk about the exceptions, in the next video I will talk about the API documentation via the Sphinx system. Okay, so let's start with the exceptions. In order to demonstrate a few things on exceptions, I would suggest that we are starting on a Jupyter notebook in order to just demonstrate what we are talking about, these exception things. And let's just create a new Jupyter notebook. Let's call it a new Python free Jupyter notebook, and let's just call it just that if we give it the proper name, the untitled is not that nice, let's call it exceptions. So this would be basically the demonstration for the exceptions. Okay. Now, when do these exceptions occur? And if you look at the slides, it's already shown there's an immediate example. If you try to do something which Python cannot do, then typically what you get in an exception. So let's assume I have a string where I just put the number 1 in the string, and then I'm trying to convert this strings to an integer. And as long as the number is 1, so the number which is the string which is stored represents a string representation of the integer, it works everything fine. Now let's assume, for example, that could be a user input. The user inputs the wrong thing. So for example, it writes AB, which cannot convert it to integer. So what happens? We basically get the so-called value error and the so-called traceback information, which tells us that basically in line 1 of this cell there was an exception. And here the value error is the kind of an exception which happened, and here is also some text which tries to explain what was the problem, why Python could not continue code execution at that point. And this was of course that there was an invalid literal for int with base 10. So basically this AB string could not be converted to an integer. Now just to have a feeling for that, what happens here, let's here add an additional print statement. Let's say after conversion, and let's try first to run an example again by using just the usual integer 1, and you see after conversion is printed. And now if I'm just making the wrong string, then you see that after conversion is not printed. So basically at that very point where a so-called exception happens, an error happens, Python stops execution, and basically the command here, the print command after that, is not executed anymore. So basically that's the first thing you should realize. These exceptions are signalizing error conditions, and the program execution stops at that point basically. So the next lines, usually unless you are making some precautions, some constructs, the lines before will not, the lines after will not be executed. Okay. So that's the main thing, and as explained also on the slides, basically the thing which you should watch at is the value error, so what kind of exception it is, and especially the error message, so what kind of error was which was raised by Python. The nice thing is with exceptions that it can give you the exact location where this exception was raised. So let's assume that we are turning this conversion into a subroutine, into a function. So I will just introduce here, let's say convert to int, and then it accepts text, and basically it should return the integer representation of the text. And then I will change my example, and my example will be changed now. Instead of writing in myStir, I will just use, okay, let's execute that to make sure that Python knows about this definition, so that here then the auto completion works. So convert to int, and I am just passing it the number 1, and it seems to work. I can even print it. Print, so the result then is 1, and after conversion. Now let's try here to give this string which doesn't represent an integer. And you see, first of all, that again the second statement here was not executed. That's the first thing. And the second interesting thing is, a part of the error message, which is still the same, you have basically no the so-called traceback information. So basically you get an information where the error happened. So you see the error was happening in the print convert statement here, where we were using this print statement. But then you see that in this statement we were calling the function convert to int, and within this function convert to int, it was this line, the second line of this function, the second line of this function, which was generating the error. So basically with the traceback information you get a full detailed information. How did you reach the point from the main code? How did you reach the point where the exception was raised? And basically all the points where the function was called which was raising the exceptions are basically here shown, and also the line within the function which raised the exception. So it's very easy to find out where the exception was raised and how we ended up via which function calls we ended up at that exception. So this is very handy to find out where the error comes from. Of course, the big question is whether is that kind of error something which the user of your code should see, and usually that's rather not the case. So let's think about an example. Let's assume we have some kind of program which reads in a file, and let's assume the file name is something which the user of your program can provide. So basically that means that your program can operate on arbitrary files as long as the user provides its name. And let's say this is called test.dat. For example, this is the name which the user provided, and usually what you try to do is you try to open basically the file, right? So open, let's say, fname with the reading flag, and then maybe you just try to read out the data, and then you close it, right? So let's have a look at this portion of the of your code. Now you remember we have learned that instead of this one you could use the with open fname r as fp construct context manager, and then we could basically leave away the close. But for the moment I don't want to do it. We will do it later because I would like to demonstrate something else first. Okay, so let's try to execute this thing, and immediately we get a file not found error. But if your program is a nice written program package, you do not want to face the user that kind of internal information like an exception has been raised, but you more want to be able to catch this exception. So basically being notified that this exception happens, and instead of having this detailed information on the screen, write out something else, or maybe even make some default action instead. So basically if the file was not found, you could eventually, in some cases it could be useful that you are using a default content instead, or you are just writing a nicely formatted error message and stop the code execution. But seeing something like that on the screen is not very nice. Okay, so basically the next topic we want to discuss how to catch that kind of exceptions. And basically in order to make sure that Python is not immediately stopping code execution, we will just get the so-called try and except clause, which means that you have to put in the code which is likely to throw an exception after a try, and then you get an except clause where you basically specify what kind of exception you would like to treat, and if such kind of exception appeared, for example file not found, then you can do something here. Okay, so let's try it. We will just apply here. So step by step. So in order not to get this ugly error message, we can say try. Okay, fp open. So we try to open it. Fine. And then except. So basically not the file not found error, and that means that if this file not found error happened, then we can just notify the user that the file let's put it into could not be opened. So basically we are notifying the user that this file could not be opened, and just we are passing the file name fname to that. Okay, what else? Maybe we can you do here something, or we can stop the code. Otherwise we can also make an else clause in case this has the opening of the file was successful. We could just say txt is equal fp.read and fp.close, right? And here we could just set txt to the empty string, which would signalize the main code that basically it was the empty that no text was read. Or we could even set txt to none, for example. That could be also a possibility. And then we know if it has been set to none, then we know that that means that it could not be read. Now let's try to execute this code snippet, and you see it looks now much better. The result, it just says file test.dat could not be opened. And if you now print out the value of txt, then you see that it got none. Now let's create such a file. Okay, so let's have a look whether the other part of the code works correctly. And I will just open a file test.dat, and we just write this thing some test inside. I mean, it's not really important what we are putting inside. And now if you just with cat get the content of the test.dat, you see that there is a string called some test inside. Okay, and now let's try here to run this thing again. And now theoretically the file exists, so we would hope that here the second part is executed, so text is indeed read. At least we didn't get any message, so this print has not been executed. And if we are printing indeed the content of the text variable, now it contains the content of the file. So this worked. So far so good. So basically here we have basically covered both cases where exception was raised or no exception was raised. Now before we continue, let's try something else. What happens if the file is there, but for some reason it cannot be read? So if you remember, if you on the flags, on the attributes here, you know that this means that the user can read and write the file, and the group can read and write the file, and others can read the file. And now, for whatever reason, I will just change it in a way that all, so everybody, user, group, and others, should be neither able to read nor to write this file. And if you just get again, you see that basically there are no flags specified. Now what would happen if I execute this code again? Right, it would try to open the file. It may even work, we will see. But the file is for sure there. So basically this thing will be definitely not raised. So let's try it, what happens. And then, oops, I got something else. I got no permission error. And the permission error, it tried to open it, but it could not. And but it was not file not found because the file was there. So it was a different kind of exception which was raised, a so-called permission error exceptions, because the permission was denied to test.dat. And of course, I could also handle this one by writing something like except permission error, and then I could write print file could not be opened, wrong permissions. And here I could write could not be found because it was not found, and it was not could not be executed or opened due to the wrong permissions. And then fname format I just include to that. Okay. And now if I basically do it, then file test.dat could not be opened, wrong permission is here, so indeed, and of course here I would have to handle, of course, also here txt is none because I could not read in the text. Maybe it is even better if I just set txt by default to none here at the very beginning. So I say txt is none, and then I can just execute it, and then txt is always none unless I really manage to read in the file, and so on and so on. So basically you see that I can specify various different accepts, and basically I can make an accept for every permission I would like to deal with. The only problem with this approach is that, of course, there could be a lot of different exceptions which can happen during opening the file, and that's very complicated to look up all of them and basically to write also the same code to all of them. and therefore basically exceptions are ordered, and exceptions are ordered into so-called hierarchy. And I will just here show it immediately. We will go back to the previous slides in a second. But you see that basically all these errors, file not found error and permission error and even a timeout error, they are basically children of a so-called parent exception class, which is OS error. We didn't talk about the object-oriented programming much, but basically this inheritance is a very basic concept of object orientation, and that only means that all the parent, all the children types, the children type file not found error, the children type permission error and timeout error, they are all inheriting the properties of OS error. For us, it's very important that basically we can, instead of listing all those errors here one by one, we could just tell Python, look everything which is a child of OS error, or is either OS error itself or a child of that. So basically, instead of having these two lines, these two excepts here, we could just do the following. We could just here write OS error, and then we could just say file could not be opened again, and the reason doesn't really matter. So basically I can just take it out, and then if I execute it, it's although it was only the permission which was not working, it was treated in that except clause, because as we have seen before, here the permission error is a child of OS error. So basically if you write OS error here, then you are catching, you are basically here dealing with all the exceptions. No, sorry, this was not what this I wanted to show you. With all the exceptions which are associated with that, which are children of this ORF. So it's basically, you can think about that like a hierarchy, like a tree structure. You have one node at the beginning and you go down in this T structure. And when you have the node OS error, then from this node OS error, you have 3 branches or even more: file not error, permission error, timeout error, and so on and so on. And basically, if you write OS error, then all the things which are below that in this hierarchy are also treated. So basically, with this thing, I can catch the error, and it doesn't matter whether the error occurred because the file was not found or because the permissions were not correct. They will be all dealt because both errors are children of children classes of OS error. So basically, this way I can treat that. I could maybe even, to make it even more robust, it would be probably easier and better in terms of strategy to take also this guy here, the reading, and then also here, let's say the closing. That would be also a possible strategy. Then it's still the same happens. Why? Because at the open the exception occurs. Whatever comes after the open is not executed anymore, but Python is jumping to the except clause, checking whether the exception which was raised is this exception or a child of this exception. If yes, this thing here is executed. Otherwise, the code execution is continued after the try block. So here I just say after try block, and then you see that basically it could not be opened, and after the try block, and I will also just print the value of the variable txt so that we can see it, and the value is none. Now if I just change back here, so basically the attributes, so basically for myself, for the user, I am adding the read and write flag again on test.dat, and then if we execute here in the worksheet, this exception handling and opening, if we execute it, you see this was not executed anymore because there was no execution, no exception raised. Therefore also txt has been read, so this line has been executed, and also this line, and then basically code execution continued here, right? Okay, good. Now the only problem is, okay, I'm catching now the generic exception OS error, but what happens if I want to tell the user, okay, but what was the reason? So basically here now I can just say, okay, the file could not be read. Actually, it's not even opening. It would also end up here if I have an OS error during the reading or if I have an OS error during the closing. So basically I can say, okay, I could not read the file. So far so good. But is there a possibility to tell the reader what was the original message of the exception which Python raised? Because that may be helpful in order to interpret the error and maybe try to fix the error. And indeed, that was which was shown in the earlier slides, which I just jumped over. And that is basically here you can see that you can also take the original exception and store it as a variable. So basically exceptions are nothing else, just a variable which is created. The variable has a type OS error, for example, if it's an OS error exception, and it has a certain content. And the content of this variable is, there are two important contents. The variable itself can be used as a string, so print out what Python would have written out, and each of them has arguments, so-called arguments, which are storing some relevant, may store some relevant information. Okay, so let's do that. So basically here I will just say OS error as, and typically usually you are using EX or EXC in order to get the abbreviated name for an exception. And then here we could just say, okay, print original error message, and then we are just basically doing nothing else, just appending the exception itself. And the exception can be represented as a string, and then it will contain the original error message. No, of course this was not executed because the file is okay, and basically the file could be read in. So basically what I will do is I will just u minus rw, just revoking the read and write flag for myself. Okay, and now I will just try it, and let's see what happens here. If I executing it here, then it says test that could not read, and you see the original error message is basically that the message, the error message of the exceptions which you have seen, would have seen if you hadn't stopped it or code the exception with the except clause. So basically this way you can pass the user some additional information. You can say I could not read, and that was the original error message. And the original error message is nice because it says it was a permission denied. So the user immediately knows, okay, the reason why it could not be read was that it was permission denied. Sometimes exceptions also have the exception variables, a part of being printed as a string, which contains the error message. You can also have a so-called arguments, exception arguments, and we will just print it axc.args, and let's see. And the exception arguments, you see it's a tuple. It contains for 13 because it's the error number 13 and a string. However, these exception args are different of different exceptions, right? So basically, if you want to know what those arguments exactly mean, then you have to look at the documentation of that given kind of exception to understand what is given in this tuple, what kind of information you can get out of that. But it's true for all the exceptions that basically the exception itself, if it's converted to a string, so basically you are using, for example, in a format statement as a string, then it will just contain nothing else, just the error message itself, which Python would have written on the screen if you did not handle the exception. Okay, and now as a last test, let's try to delete this file. So I will just remove test.dat so that it's gone. So test.dat doesn't exist anymore, and now I will just execute it again, and then you see that now it's changed. The original error message is error number 2, no such file or directory test.dat. So basically again the user gets a hint, apart of the fact that okay, my program could not handle this file, could not read in this file for whatever reasons, but basically it gets also more detailed information about what happened, and okay, no such file or directory, so it's clear the file name which was specified is not existing. Good. And last but not least, let's try us to do the with construct with the context manager, because this is also a nice thing, and we can spare the close things, the closing of the file explicitly. So just to demonstrate it, at the end with open fname, and we will have the read flag as fp. So basically we are spanning here, creating a context manager block. What does it mean? It means that whatever happens here we can say txt_fp.read, and the nice thing is this context manager makes sure that whenever you leave this kind of block, the context manager block, basically the object here which was created will be finalized. That means the file will be closed. So basically you don't have to close the file yourself, you are just opening and reading it. And then if you leave basically this open block, this with block, sorry, then the file will be closed automatically. And it does not matter whether you leave this block because of an exception or for other reasons. If the file has been successfully opened, so as for example it could happen, then you will basically here close the file in for sure. So that's something you can use, and of course if you execute, basically the result will be the same. Okay, so here this way basically we know how to deal with exceptions, how to catch exceptions, or deal with exceptions which Python generates. Now the question is, could it be interesting for us to generate exceptions ourselves? And if you think about our project, the linear solver project, then it may make sense. If you remember, in cases where the user was passing a linearly dependent system of equations, then instead of the solution vector, we were returning the entry none. But there's also an alternative way to handling with this exception, and you could just basically, because you're writing a library which other people will use, and then instead of returning none, you could just return an exception. And then basically the people who are calling your library could basically handle this exception and make a try block and see whether the exception occurred. And if the exception occurred, then they would know that okay, that's because basically something is wrong during the linear algebra, and then they could basically act accordingly. So our next task would be basically to demonstrate this one. So we will just go back here to our framework, and basically now in the slides we were covering everything which was had to do with the try and except blocks and the hierarchy, and now basically we will go to how we can raise an exception ourselves. Oh, by the way, maybe one last thing to one slide which I didn't mention is if we go to this example here, sorry, what to do if we could not handle the exception. I mean, one possibility is we are just here continuing, and internally with the text setting has been set to none. So basically here at some point we can later make a test and say if txt is none, then doing something, otherwise doing something else. But sometimes this is not what you desire. Sometimes what you desire is really, if it is a program, a standalone program which is executed from the command line, sometimes you desire just to stop it. And then after having told the user what the problem is, so please always stop it after you have given out some meaningful error message. And basically that, if you want to do that, you could in theory use the sys.exit method. For that, of course, you have to import the sys module. And the sys.exit, you can even pass a code to that, an exit code, which should be non-zero, and then basically Python would immediately cease the execution, stop the execution of your program here, exit with an error flag of 1, and this error flag can be checked by the operating system to understand whether the program execution was successful or not. And then basically here, if you do the same here, in the Jupyter notebook, then it's a little bit more complicated because the Jupyter notebook does not exist, fortunately, because otherwise it would kill the entire Python session kernel which is running in the background. But then if you want to create a normal executable script, then that will be that one way to exit, to have a premature exit. So basically exit the code if you cannot resolve the conflict or the problem which occurred. Okay. Good. And now let's come back to the raising of the exception. And in order to do that, I think just do it in the Python, not in the IPython notebook, but in Spider. So basically, I will just start the Spider here, the Spider free development environment, and let's come back to the example which we discussed. So if you remember, we have setting up the code or the exercises. In the exercises, you had to set up the code in order to solve via Gaussian elimination a system of linear system of equations. And here we had basically one case. We have this partial pivot, we have basically this line pivot or partial pivot, which exchanges rows in the matrix. And basically, if after the exchange of those rows you have a 0 on the diagonal, then it's clear that your linear equation, system of equation, is basically linearly dependent. And what we have done, we were returning a none if that was the case. And if you look at how we tested the solvers, you know, if you write a project, you always have to have tests which are checking the capability. We were just basically testing for the linear dependent system. So here you have already the parameterized version of the code where we are running with the decorator PyTest mark parameterize the test linear dependency function on the tests which are basically defined in the list test linear dep. And it turns out the test linear dep is one single test here, which I stored in the test.the folder. And then here I have the different files. And there is one file which is called linearly dependent.in, and you see that basically here I have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and we know that this matrix is linearly dependent. Okay, so basically here, just coming back to the test, and then I am just reading in and checking whether what the solver was returning is indeed none. Okay, and basically you remember you can just run it with run and run unit tests. And if you run it, then basically at the moment the unit testing working quite fine. All my tests are indeed succeeding. But now I would like to change it. And I would like to change my program in order to make sure that I am not just returning none, but I would like to make something more crucial. And I would like to raise an exception. So generate the same exceptions what Python would have generated if something similar happened to Python. And the first thing here is to decide what kind of exception we want to raise. Basically, you can raise any exception from the hierarchy which we had, and one of the exceptions which is usually would fit is the so-called value exceptions. Why? Because basically the type of the object which the user entered is probably fine. It's an array, a float array, but the value which was contained inside was not correct. And the reason, the way to raise that exception is basically that I could just define the message which I want to tell the user. This is exactly what the user will show at the end of the exception, and I could just say that linearly dependent A matrix, linearly dependent matrix. Okay, and then instead of returning none, I would just create a value error object, and this value error object I'm passing just the message of the exception. Okay, and then basically that's it. This is not very complicated, but instead of returning it, I don't want to return it. I want to make sure that an exception is made, and that's the keyword raise. So raise value error means create an exception, a value error exception with the message which is passed as the first argument, and basically raise this exception. So basically stop code execution here, exit the routine if the code which we have here is not in a try and except environment, and go to the higher level and try. And then it's basically the task of the higher level routine to raise that exception. Good. Now that we implemented that, let's try to run it. So let's just try to run the run tests. And if we run it, we see that there is a failure here. And why is the failure here? The failure is in the test name linearly dependent. Here the PyTest shows what the problem is the line xCaus is equal solver Gaussian eliminate, which is good. So basically we are talking about this line here. And what was the problem? If you just scroll down, here you see all the arguments. And the problem is that it was raising an exception, but a value error exception. But PyTest is not expecting that an exception is raised, but PyTest is accepting that here none is given back. So basically we have somehow to make sure that PyTest can treat the exception. And one possibility is or the simplest possibility, which you usually should not use, but this would be the straightforward thing to implement. We could just do this in a try block, and then basically we could just look for exception value error. So basically, if there's an exception raised value error, we can just here catch it as exception, or maybe no, we don't even need it. We just accept it, and then if that's the case, then we would say that xGauss should be none. So basically, if this exception was happening, then we are turning it back its value to none as it was before, and then the assert is xGauss is none. It's quite good. So let's try to execute this one. Now, if I'm running the tests, then with a little bit of luck, they are all working again. And this demonstrates that this try and accept can be far away from the code where the exception was raised. And this is a nice thing about exceptions. Exceptions are bubbling up. That means I was raising the exception here because in this code there was no try and accept block. So basically this exception was not handled here locally. Therefore the code execution of Gaussian eliminate was basically stopped, and the program execution goes back to the original place where Gaussian eliminate was called from, and you can here treat the exceptions. And that's very typical for exceptions. If you have many calls, a function calling another function, calling another function, calling another function, calling another function, if this lower level function at the bottom of the call tree makes an exception, then the exception goes up to the point where you have a try and accept block for that given exceptions. If you don't have any blocks of them, then of course the user will see this not very nice, this awful exception trace and the exception message. But if you have somewhere in between in this function call graph a try and accept block, then you can treat the exception. Okay. So far so good. So this way basically we can catch the exception. However, I would like to point out that this is not the right way to do that in PyTest. There's a much more elegant way to do that, and basically that's it's shown here. And here we can just basically test for that with pytest.raises. So there's again a context environment in PyTest, which can be activated with pytest.raises. You are passing in the type of the exception you are basically accepting, and then you are doing something. And let's give it a try. So we will just say with. And then if you look at the slides, you see that pytest.raises, we need pytest.raises, and then we have to which exception is expected, and that's the value error exception. And basically here we are just calling x and Gaussian solver, and that's basically everything which we need. Now we can just test whether it's working or not. Let's run a test whether it has the desired effect, and indeed you see that this is okay. Why? Because that exception was raised. Now let's assume I am writing here a different kind of expression, so a type error, which is also a valid expression. Let's try to see what happens if I'm running the tests. Then the last test fails. Why? Because it was the wrong kind of exception which was raised. So basically here it was expecting type error, but here no value error happened. So basically that's the wrong type of exception. Also here this thing indicates that the variable xGauss is not necessary here, because we are not doing anything with the result of that, and that's true. I could just also drop it and just execute solver's Gaussian without storing the result, because the result is not interesting. It should raise an exception anyway, and if it doesn't raise an exception, then something went wrong, so the result is not interesting anyway. And this is something we could also try. So let's change it back, just for the sake of curiosity, what happens if I'm just changing back to the original, here the original way, which means returning a none instead of raising an exception. And now let's have a look what happens if I'm running the solver tests. and then you will see that basically here I get a failure. Why? Because PyTest expects that here a type, sorry, I wanted to change it to value error, but it doesn't really matter in that case. But just to be more pedantic, let's change it back to value error. But still I get a failure because PyTest accepts here an exception to be raised, which doesn't happen. And this is exactly the reason for the failure. So if you just scroll down, then you can say, aha, error failed because it did not raise an exception of the class value error. So basically the nice thing is, basically this test will be fulfilled if during the code execution within this context manager environment, within the with block, if the exception which is specified here has been raised. So let's change it back again, the solvers.p to the new implementation which raises an exception, and then if I'm running the solvers, it should be all fine. Okay, good. The last thing which I would like to mention is that sometimes it's not that easy to choose a Python exception which would fit for you, right? So sometimes you have to invent new exceptions because none of the one which Python usually raises is the correct one, and that you can basically do by defining your own exception. So basically exceptions are classes which are, as I said, inheriting from previous exceptions, existing exceptions. And the way to do that, the proper way to do that would be, if you wanted to do that this way, let's say instead of value error, which is a little bit unspecific, we could just specify linear algebra error, linalg error. This is exactly similar to what NumPy does. Of course, I cannot raise this exception yet because it's this unknown. So basically, I have to say the code what linalg error is, and that I could basically here define as an exception class linalg error, and I have to test. I have to say from which exception it should inherit, and it always, if you are doing your own exceptions, you would have to inherit from the exception class exception. This is the highest exception class you should use in order to introduce your specific exceptions. And then basically I'm not doing anything in this class, I'm not changing something, I'm just inheriting, and that's it. And now I can basically, if you go down, you can see that you can use linalg error, and then basically in the test solvers.p I can check whether this the module is called solvers.linalg error occurred. And now if I'm running it, run tests, then it seems that it works perfectly. So this way you can introduce your own exceptions, even your own exception hierarchy. But my advice would be, do not overdo that, right? So it's not that typical in Python to invent 20 new exceptions. You should only do that if none of the Python exceptions are well suited for modeling or telling the user what's exactly the problem was. Otherwise, you can just reuse Python's own exceptions, like the value error would have been also okay. Good. So with that, basically, this I told you everything which I wanted to tell you about exceptions. I hope that it made sense to you, and that now you are in the position to handle exceptions and also raise exceptions if needed. Thanks a lot for your attention, and then see you in the next video for dealing with the API documentation. Thank you. Bye bye.